Hello, Mr. Angus Wangus back. Time for a new video. Show you or talk about what I've been doing and thinking. And most recently, I've come to discover or been shown that the windings that I've been using and doing. First of all, we're bucking coil designs or configuration. And here recently, in the last few weeks, I've been using what's called a G-field setup, or Kromrey is what it's very similar to, which is what I'm going to talk about here, because I've gotten this patent and read it. I've read it once, but found some very interesting things. I guess very first of all, it's the man's name was Kromrey. Oh, shaky. Anyways, I wrote it up here. Kromrey. And I thought about waiting 2 days to make this on the anniversary, but that would be silly. Anyways, there's the patent. There's a few more diagrams that go along with it. These are the ones I want to look at. And of course, now that I've got the wheel winding up, I'm seeing that I'm having a problem here that I need to solve one-handed. Alright. Just to make our discussion better. Okay, so I've got the wheel winding up is what I'm doing. This is going to be, I'm going to edit together a whole bunch of snippets. Hopefully it won't turn out too long, but basically what I'm going to do is give a demo of the flywheel effect and what I've been discovering with that and learning about there. Because I really didn't know anything about flywheels, come to find out. But anyways, that's what we're going to talk about and look at today, because it's a very important design feature of Kromrey's device, and also Ed Leeds-Gallman's, if you have a look at the cement and the weight that's involved there. But what I'm doing is I've just started it. I have the same resistance in between going to the source and going to the motor as I have been using. So we're going to look at the top end speed with the input that we've been using. We're going to look at the top end speed with no cores next to the wheel and no flywheel happening at all. Now what I'm going to do is, for this video, is make snippets of experiments, tests with these microwave oven cores that I've chopped up in this past week. Actually, I made like 12 of them, and they had to be in pairs, the same weight, so I had to make sure I chopped them same number of laminations. But I've got a bunch of pairs, but what I'm going to do is add them to the wheel, and we'll have a look at the flywheel effect. But first, I just wanted to look at the Kromrey patent. And I've read it once, and I need to read it over and over, but really happy I found the correlation between what I'm doing and this Kromrey patent, because it's just reaffirms what I've been thinking. Very first of all, the very first thing I notice from this diagram is that the flywheel here is a very important aspect of his design. He talks about it in the patent, and how that was an important design. Now, John Bedini made a replication of this Kromrey device, but his replication, and I think he had it and showed it in Energy from the Vacuum video, but his basically was from here up. He didn't include the flywheel, and that was hinted at by him in that video as to how he could make it more efficient. But he didn't tell, of course, right? And just to say that I've looked at all the other replications on YouTube, and they all have copied Bedini's design without the flywheel. And Kromrey details the importance of the flywheel and how it operates and how it has to do with the speed of the wheel. But the very, very, very interesting thing I noticed was the schematics that came along with the patent, referring to the winding directions. And now you have to read the patent and understand the directions here. of the windings, but I can see right away that these coils are wound in opposite directions. These two are wound in the same direction, and these two are wound in the same direction, but side to side they're wound oppositely, which is the two armatures of his device up here. And just to note that this drawing in the patent is for a different purpose, not so much to show winding direction, but to show the connections with relations of the poles of the coils one to another. That's how they write these patents. And they write an intro, they write a description of the operation, the underlying method of operation, and then they give a physical description and concluding comments. But one very, very interesting thing I want to point out is that in this patent, and I'm actually going to read this small part to you, and he explains things very well, obviously, in his patent. But I just want to read this one part. It says, when the output circuit is closed, part of the work is translated into electrical energy as the current flow through the winding opposes the magnetizing action of the field and increases the apparent magnetic reluctance of the armature. This explains why, in a system embodying my invention, the speed of the generator remains substantially unchanged when the output circuit is either opened or closed. And his descriptions in his patent here are great, answer a lot of questions as to what I'm doing. I was on the right track in my understanding, but this reaffirms things, his understanding and detailing in the patent. So what I want to show here is the input and speed of the wheel in this first snippet. So there's nothing next to the wheel. This is just the same input, how fast the wheel goes, and at what input. So here's our input. We have volts and amps going into the motor. 2.30, 2.29, 2.30, and 7.54. And the voltage here, I'm suspecting there's 14 volts when the motor's not running here at the terminals, and I'm suspecting that the 14 minus this number is the actual voltage. Maybe someone could clear that up for me, because I don't know everything, especially about electricity. So what we're going to do is, there's the input, and now we're going to look at the RPMs of the motor with nothing next to the wheel. Let me hold it still. And it's been running long enough to be where it's going to be and settle down. So I think we're going to call this 442 RPM. And I'm just going to jot it down here so that I don't. And I'm not going to do it left-handed though. 442, and our input amps are 2. We're going to call it 2.29. 2.29. Input voltage 7.52. 7.52. Okay, so what I'm going to do is turn this off, and I'm going to put weight on the wheel to show a flywheel effect, and I'll be right back. Okay, back for part 2. I've written down the freewheel speed that we had in input, and now what I've done is I've taken 2 of these pieces of, these are microwave oven transformer cores, and I've cut them into pieces, chunks that are equal in weight. And what I've done for this snippet is I've strapped 2 of them on this wheel. I'm afraid to get in line with it. So there's 2 of them on there, 1.5 kilograms total. And we're going to have a look at what it's done to the input and speed. So the input now is 2.36 amps at 7.15 volts. They're slightly jumping, especially the voltage, just jumping slightly. And I've had it running, it's settled. And the RPM, oh, if I can hold my hand straight again. Is 366. And I'll change that number then. 366 is what we had at this input. And so obviously it slowed the wheel. Now yesterday when I was doing these tests, the next thing I did was to put a core next to it and try it. And it takes a lot of time. I don't want to do the whole thing over again, but I want to give you guys a picture of what I've been learning about flywheels. And again, most of you maybe know this stuff already, but I wanted to make a video of it because this is what I've been learning lately, and I have been working at this. And I had a road trip last week which almost killed me. I mean that I had to recover from just sitting in the car. But anyways, my next line of thought was to put a core next to it and look at the torque, how the torque has changed, and it really didn't. From this to where I had the core next to it, as compared to no flywheel weights on the wheel setup with the core next to it, the change was about the same. So we've had a slowing in RPMs. We'll have another look right now. We've had a slowing in RPMs, 366. And the input has increased from the freewheel speed. So next, what I'm going to do is, in the next snippet, I'm going to take those weights off the perimeter of that wheel, in the second wheel in the back. They're strapped to the perimeter. What I'm going to do is take those off, and I'm going to strap them to the shaft, and we're going to look at the difference there. And what I'm going to do is I'm going to strap 4 of them to the shaft. And then in the snippet after that, I'm going to strap 8 of them to the shaft. And we'll look at what's happening. But there you go. And I'll be right back. Okay, back. Now what I've done is I had these weights strapped onto the wheel, like so, onto this extra wheel. Trying to get everything into focus. So now I've taken those off. We saw that how that slowed the wheel down, and in my experiments yesterday I could see it didn't give me any torque, extra torque. So now what I've done, now I've got 4, that was just 2 of them on here, had that bad effect. Slowed it from 442 RPMs all the way down to 366 and increased the input required by the motor. So now I have instead of 2 on the perimeter of this wheel, now I have 4. So it's double the mass, actually, double the weight. It's 3 kilograms. And again, these are chunks of microwave oven cores. And now I have them strapped on the shaft. So we're going to get it going. Give it a flip. Get her going. And it'll crank up to speed. I have everything written down. We have our freewheel speed and input. The perimeter flywheel, that was 1.5 kilograms. It went 366 RPM, and the input increased from the freewheel, right? So it reduced it quite a bit, 80 RPM. So now we're going to see what it does with double the weight, but on the shaft this time. And look at the input. Now to go with this, I'm going to be continuing this, but I want to show you where I'm at with this flywheel testing because I think it's fascinating. But what I need to continue on after I show this snippet and the next one later today and the next few days, I'm going to be testing the torque that this is giving me because I need to know. So we have 3 kilograms on the shaft, and if you try this at home and you're putting heavy things on a spinning wheel, make sure that they're securely fastened. If one of those things came off, it would go probably literally right through the side of my trailer home here. But yeah, we're at the very close to the input of the freewheel speed, and it's not settled yet, I'm sure, but we're going to check the RPMs. Let me get it settled down. It's still on the rise, so we're going to let it settle. I guess I should have started that before I hit record. But she's going to continue to speed up. She was still going. Now in the next snippet, what I'm going to do is, as we let this speed up, I'll let you know, the next snippet I'm going to add, I'm going to double that, so it'll be 6 kilograms on the shaft, and we'll see what happens there. And again, I have more to do here with testing the torque with the core next to it, but I wanted to show you where I'm at because I'm seeing cool things and learning about flywheels. And again, there's probably a lot of you out there who already know these things, but my understanding of flywheels wasn't what it should be, I'm finding. So I just want to share it with everyone. So we're at the same input now, amp-wise, as the freewheel speed. And let's check our RPM. I understand that moving them to the shaft is going to be less work on the motor, and that's what we're seeing here. And what I'm wanting to know is the mechanical advantage that I'm getting, if any. But one thing I want to note here, okay, so we're getting closer to our freewheel speed. That could continue to climb a touch. But we're noting that the input is either the same or seemingly a little less than our freewheel speed, right? Or freewheel input. And our RPMs are very close to the same. .437. So I'm going to rate this down. 437. Uah! 437 RPM. And our input is 2.28. Amps. I guess we better call it 2.27. Amps. And I see it was flashing even lower. 7.40 volts. And we're going to have a look at the RPMs again. .436. So it settled down at 436. And this input, and that's with 3 kilograms on the shaft. Now we can see that our RPMs have slowed slightly, but seemingly our input has gone down. So now what I'm going to do is turn it off, and I'm going to double that again. So I'm going to put 8 of those core pieces on there. It'll be 6 kilograms. So here we go, and I'm going on to the next snippet. Okay, final snippet. Now I have 8 chunks of that microwave oven core on there, and it's 6 kilograms, and it gives us 427 RPM. When I aim it properly. Let's give it 428. I've got it written down as 427, just for simplicity, and I'm not scrambling around. Our input is 2.29 amps at 7.4 volts. And again, this is just jumping slightly. So basically, and to go with all this again, right now is what I want to do is look at the torque, if I'm getting any torque, because what's happening here is that my RPM has slightly reduced, not compared to the RPM up here where the weights were put on the perimeter. And I know this is common knowledge, you know, the weights on the perimeter as opposed to the shaft. But I want to see what sort of usable work I'm getting in return. So I'm going to be doing more testing just to make that clear. But basically, with the very small weight on the perimeter of the wheel, our RPMs went way down, and our input went up, right? And our input went up. So when we added weights to the shaft, our RPMs have gone down slightly, right? But our input hasn't changed much from the freewheel speed and input, right? It really hasn't. And again, this is flashing back and forth between 740 and we have about 2.3 or 2.29 is what I just wrote down a second ago. So hardly any change in our input. So again, I want to see what kind of mechanical advantage I'm getting, if any. Because I am coughing up some RPMs here. But if I'm getting a good increase in torque, that would be good. Now I have tested the torque with regard to having the weights on the perimeter, and there wasn't, for the amount of RPMs you lose and the input in increase, there was very negligible, if any, increase in torque having a core next to it, with the core attracted to it. So I guess just finally, this representation here of the weight on the shaft, and again, this is very obvious, I know this already, but I want to make a video of it. Very slight decrease in RPMs, and again, the input stayed about the same, and I want to see what the mechanical advantage is. Now where I'm going next is going to be, I'm going to be making 4 coil sets that are identical. So I have to make 4 spools. Spools are kind of a bitch to find or make, even, I'm finding, or found in the past. So this is what I'm going to do today. I'm going to test the torque But also next, I'm going to be making 4 identical coils, as identical as I can make them, so that I can test this Kromrey arrangement like he has with. And what it'll be, what I'm going to test first is I'm going to have 2 PMHs on here at 90 degrees. This is the way I'm going to try it first. And the 2 coils on this set are going to be wound in the same direction. The 2 coils on the other set are going to be wound in the opposite direction, and I'm going to series them together. And that's how Kromrey's patent reads. And I don't think anyone's replicated even just that winding arrangement. But it's clear in the patent. That's how it should be. And one final note to let you guys know, I'm taking this apart and I'm going to be rebuilding it on this board because it's really very shoddy, and going to be going with that. I have a little different arrangement with my coil wiring. I have them parallel, turned around and in parallel. I'm going to be talking about that in my next vid. I'm going to show the output that I'm getting now from one coil set is 30 volts at 200 milliamps, which turns the wheel very well. And that'll be my next video showing that demo. I want to get this reconstructed. I have more testing to do here with the torque in relation to what I'm doing with the flywheel. Yeah, going to be looking at that. So these are the things I'm doing. I'm going to make 4 identical coils and start testing the Kromrey arrangement and other arrangements. And with 30 volts at, it's actually 210 milliamps, turns this wheel very well. And 2 sets of them is going to do very, very well. But that'll be my next vid, a demo of that. But give me a little time, guys. I've been busy. Again, I had a road trip this week that took me 2 days to recover from, sitting in the car for 8 hours. But other things going on too. Had a build here at home, and I have another build construction project that I need to do as well right away. But I'm still working at this. Wanted to make a new video, and I'm going to edit this all together. And there you go. We've talked about the flywheels. We've talked about my direction. And what I'm going to be doing here. And my next video is going to be a demo of where I'm at with the output with relation to driving this wheel, and I think you'll like that. But I've been working hard at this still, guys. Haven't had a vid in a week, but there you go. Wanted to keep everyone up to speed with where I'm at. That Kromrey patent is a very, very good read. It reads like a list of all the tests that I've been doing over the last 2 months. He pretty much outlines them all my results there. So this is all very encouraging. And lots of things to test and try here with regard to that patent that I've seen other replications. They haven't replicated, I don't think, the windings correctly. And again, with the flywheel effect. Now this flywheel effect is also dependent on the RPM, which Kromrey details in his patent. That's a good read. But this is the reason why I'm testing this flywheel concept, because I'm going to incorporate it into my design. But there you go, guys. Next video is going to be another demo of the output, driving this wheel. I'm going to rebuild this and start testing and moving things over to this wheel, finally. There you are. I'm going to stop blabbing, and I'll talk to you later.